That's what we did get into last time a little bit. We're finally getting closer to full reality. The reason I'm doing section 10.2, I could have done section 10.1, but there's so many little freaky things about 10.1, and the book does a couple things very different. I thought 10.2 would be a good taste of what's going on here. 10.3 is what we're doing now, but with percentages. So the whole idea of chapter 10 is you don't have some known value to compare a sample to. You have two samples, you don't know shit. 10.2 is you actually know the sigma. So that's why 10.2 is a little bit easier. But you don't know what the sample means. You don't know what the population means are. And you're just testing to see if they're different somehow. These two populations. You're going to take a sample and test to see if they're different. So for example, I could do a problem where, you guys ever heard of Kaplan? Nobody? So I think they're the ones that do the SAT. They do a few different test prep. So they could have a test where they say, here's a sample of students that came and took our test prep, and here's what their SAT scores were. And here's a sample of students that didn't take our prep, and here's what their scores were. And then they can show statistically that there is a difference. Hopefully for them that it's higher for the ones that took their course. You guys semi with me? Are you guys with me? What could be wrong with that though? Even if that comes out statistically significant for the group of people that took their course, what could be wrong?
They administer the test prep to kids in affluent neighborhoods.
Say again?
They administer the test prep to kids in affluent neighborhoods.
Okay, so maybe their test prep centers are mostly in areas where it's there's a factor like affluence that would already affect the test grades, right? Maybe. But the same thing happens with tutoring, believe it or not. Who goes to get tutoring, for the most part, are the students who are already good students. They just want to do more to get even better. Unfortunately, very often, the students that really need it don't go. So if you say, look at our students who come for tutoring, they have a higher GPA, that doesn't mean shit. Really, it doesn't. I know tutoring helps. I know it does. But I can't point to that to say that proves anything.
They're a self-selected group.
Yes, self-selected group. I love it. So if you could somehow force people to take this, that still wouldn't be good because you don't even know if they're paying attention anyway. All right, sorry. So that's a little side note about when you read through an article about a statistical analysis, they have to have somewhere a section of how they controlled for variables like that. If they did try to, right? If they didn't try to, you just say, that's bullshit. Try it again. Okay. So what we did last time is we remembered this dude. I reminded you what this was. And then I said we just are going to double everything now because I want this to make a lot of sense. So if I wanted to test the difference between male and female grades in the course, I'd have a population of females. I would take a sample of females. So that would be like mu1 and x bar 1. Population 1, sample 1. Then I would have the population of men, mu2, and I would take a sample of men, x bar 2. And now I want to compare those things to see how different the sample means are. Is it different enough to show evidence that the population means are more than likely different? Are you guys semi with me? Okay. So, the top should make complete sense about what's going to happen. I'm not going to just have one sample, I'm going to have two samples. I'm not just going to have one mean, I'm going to have two means. And to be really honest, this is a little more complicated than the one we're going to end up using. There's one piece of this that's going to cancel for us all the time. It doesn't really cancel all the time, but most of the time it does. The weird part was the bottom. The bottom is the weird part. So what I do for this, how do I double this stuff? I look at sigma squared. Well, I could. Yeah, sure. So then I'm going to double. So this is the variance. I'm going to double. I'm going to have two of these suckers now because I have two populations. So it's going to be sigma 1 squared over n1 plus sigma 2 squared over n2. But then I better take a square root so I don't have a variance down there. Now that one there, admittedly, there is more to the story on that denominator. But I'm trying to keep, the idea of this course is an intro stats course. This is a very surface level thing. But just that idea alone kind of makes this make sense, why it would look like this. I've doubled everything because now I have two populations, I have two samples, I have two standard deviations. I like it. Okay. So, here's the good and the bad news. It's good news because nothing really changes. The 5 steps are still the same 5 steps. There are a couple little things that change. One is going to be the formula we're going to use in step 4. And then the other step is going to be what the hypotheses look like. So let's try an example problem out to see what the hell's going on. And real quick, before I forget, normally my H naught, my null, is going to have mu1 somehow equal to mu2. There's going to be equality involved. So this is going to cancel. You could have a claim where you say, I think the men scored 9 points higher on average, and then the difference would be 9, not 0. But for most of the ones we're going to look at, it's not going to be that. It's going to be 0. It's going to cancel. Okay, I love it. Okay. So let's try a problem out. So let's say I have a population of, what's got to? It's getting warm. Population of toasters, old toasters, right? And a population of these new toasters, newfangled toasters, supposed to toast faster. So I know that the standard deviation of times for the old toasters was 4.91, and the standard deviation in times for the new toasters is 3.17 minutes. That's a bit high, but I don't care. I haven't had a toaster in a long time now. It's one of those kind of sucked in general, so Alright, I like it. Okay, so these are known. That's why I've got those suckers in there. That's why it's a z-score that I'm going to use. Just a quick note. Section 10.1, the weird thing with Section 10.1 is how do you calculate degrees of freedom when you have two ends? And what the book does is a little worse than what's accepted you could do. But then it gets a little bit twisted after that. But I mean, technically the only difference between these would be S's to calculate this score. So let's say we take a sample. We sample 41 old toasters. And we find a sample mean time of, what you got, Jeff? 8.17 minutes. For the kind of person that likes, the toast is basically charcoal. Well, that's what they like. They like to lose a tooth every time they take a bite. And we sample 37 new toasters. And we find a sample mean, become a 2, of 6.85 minutes. I like it. Sweet, I like it. Yeah, Jeff, you made it up, okay. Break. Now, one thing I want to point out right now, is anybody concerned that the sample sizes are not the same? Good. You shouldn't be. It doesn't have to be the same. No reason they have to be the same at all. I'm not going to go off on a little rant about percentages and how people think they change when you have a larger sample. They don't really change for any reason. Anyway, yes?
So they don't really like be close at all, like one could be like 100 and the other one could be like 1,000.
Technically, yes. Totally. Right? Now, again, there's always behind the scenes some adjustments to make for certain things. But that really isn't the issue. The difference in sample size, not the issue. In fact, it's going to be taken care of here. Mathematically, it's going to show up. It's going to mess up my star, my T star, or Z star. Okay, stop for a second. So, everybody cool? So they're going to have to give you like a ton of information because I got two groups of shit to look at. They're going to have to be given. And normally now, I'm being really, really nice in this problem because I'm identifying which one's 1, which one's 2. You need to pick which group is 1, which group is 2, and then stay consistent. Otherwise, things get on the wrong side and things get all freaked out. So my old toasters are population 1, my new toasters are population 2, and that's the way it's going to be for the whole problem. Okay, I like it. So what do you think my claim is if I'm the creator of these new toasters? I'm going to take this away for now. We'll bring it back. What would my claim be? If I'm the creator of the new toasters, what would my claim be?
You're supposed to call it 6 hours or close, much faster than the old law of Parakeet.
I like it. The accent and everything's beautiful. So can you put it in math terms? Let's see if you guys can do that. What's the claim being made? Don't put no X bars in the claim. I can see that this is lower than that. Why would I make a claim? I claim that this number is less than. Good job, John. What am I making a claim about?
Population.
Population means. So my claim is that mu2 is less than mu1. I want my new toaster to be quicker at charcoaling these pieces of thread, right? Now,
I'm a little confused about this. This equal to 6.85. So even if it was just like mu2 was just like a couple seconds, like just quicker than mu1, like it's a corporate thing. It says
I like it. Beautiful. I love this question because I never know if I've really done enough with this idea. A sample by itself could come out very far from the mean or very close to the mu, the real mean, right? Any sample could be different from what the real mean is. Just because there's a difference between these two doesn't mean there's a difference between the population means. If I take a sample and get a mean, will that be the same as the mean of the population? What do you think? If I take a sample and take a mean, will that mean be the same as the population mean? So if I took 148 gross month students and found an average age of them, would that equal the average age of the whole school? Okay, okay, you'd expect it to be close, but would it be equal? And what's the idea of close? Well, that's controlled by standard deviation, and that's what this whole process does, is it sees relative distance. Are they far enough apart to say that the population stuff is different? So two samples being different don't mean shit. I can take two samples from the same population and they're different. Right? Does that mean that population mean doesn't equal itself? No. Do you understand what I'm saying? So these two could have come from the same population even. This test wants to see, is there evidence to show that they didn't, that there is a difference between the two populations? I like it. If one person took 148 people and got an average age of gross month students to be 26, and somebody else did and got an average age to be 27, is either one of them wrong? No, because they got samples. They don't know. It's maybe close to 26 and 27, right? But who knows what it is exactly? I don't know. Is that Cool. So that's why you don't immediately stop when you get a sample mean that's less already or something. It's not enough on its own. It's just a sample, just a poor little sample. It's going to be different somehow. Is it different enough? That's the key thing. Is the difference you see big enough to be evidence that the whole thing is different? Yes, yes, maybe, maybe. It's okay if the answer is no, but because that's a huge piece of this hypothesis test idea. That's why we don't just stop. Look, we're done. No, it's just a sample. It's not strong enough on its own. Okay, so one thing I want to do is when you put this into HO and H1, put this in numerical order. So if mu2 is less than mu1, what's that mean? mu1 is greater than. And where would that go?
That's the high.
Yes. So mu1 greater than mu2, that's the high. So what's the low?
mu1 less than mu2.
Yeah, just the opposite. All right. So there's the first major difference. My claims have no numbers in them. Why? Because I don't have a set number to compare shit to. I have two unknown populations. My claim and my hypotheses, no numbers. They're going to be a relationship between two populations. You like it? Is it going to be a one or a two-tail test? One tail. Which side? Yeah, that's why you put them in numerical order. Trust me on this. So it matches with the Z-star formula. So you end up on the correct side of the picture. So greater than, so the tail's going to be up here. Can we stop for a minute? Just because there's no number in there, like there was back in chapter 9, doesn't mean I can't still. As long as they're in the right order, you can tell which side the tail's going to be. So now, can I use Z-scores or T-scores or nothing? Zort. Why? Yeah, so two things you got to tell me, right? Always two things you got to tell me. What's the most important thing that tells me I can do shit?
Well, you have to pick those sample size.
Both samples are greater than 30. So N1 and N2 greater than 30. Check. 2, sigma 1 and sigma 2, no. Check. So you can imagine for a percentage problem, you would have an N1P1 to check, and an N1Q1, and an N2P2, and an N2Q2. You have to check all those, because everything doubles. Everything doubles. Oh shit. I'm using up a lot of space. Okay, so third step, let me try to... Rejection region. I haven't told you this yet, but using, I don't think I did, right? No. Use alpha equal to 0.05. It's like the standard one. So it's a one-tail test. We can use Z-scores. And alpha is 0.05. So what's that going to be? What's that critical score for the rejection region? 1.645. I love it. So that step really didn't change. Z star is bigger than 1.645. Reject. No support. High. So this was the bad news part. If you are tired of hypothesis tests, too bad. There's no one. All the steps are the same. Haha. Just a couple minor differences. That's good news, though. There really is good news. There's not like a whole bunch of shit to learn for this. Just a little bit of shit to learn. Now I do my Z star. So I need, I've got all the information there. Let's go ahead and see if we can put it all together. So it's x bar 1 minus x bar 2. Right? X bar 1 minus x bar 2. Divided by a big ass square root. Sigma 1 squared. Divided by n1. What was n1? Where'd it go? 41. Plus sigma 2 squared. 7. Divided by n2. Oh, this is a lot of shit. Oh, crap. There's so many ways to put that in the calculator wrong. It's like it was meant to be evil. You still going? Okay. Oh, let's see. I might as well do it with you. Try to get what that is. I made all this shit up on the fly here. I have no idea how this is going to come up. Oh, I like it. Neat. So what do you guys, anybody get that yet? That's brave enough to say it.
Got 1.42.
That's what I got. Let's do it with green. 1.42, so shice. Find the p-value real quick. P-value. What do you guys, anybody get that? Oh, what's up? Sorry.
Can you show me how to put it into the calculator?
Anybody else have trouble with that? Is anybody else not able to get the 1.42? Did everybody get it? No, you're the only one that's
Yeah.
smart enough to admit it.
I tried to do it individually.
Oh, shice. Alright, so here you go. Put the top in. Divided by square root. And then I'll just put, don't do a parenthesis, put everything at 4.91 squared divided by 41 plus 3.17 squared divided by 37. Okay, don't put a parenthesis until you get all that stuff in there. Anybody got the p-value yet? Somebody tell me, I can't remember. 778, isn't that what it is?
Yep.
0778, that's the p-value. Which means, very quickly, if alpha would have been 0.10, we would have found evidence. Because then that p-value would have been less than alpha. Alpha was, what was it? 0.05. That's more than that. That's why we failed. So the p-value actually tells you the level of significance you would have found evidence at. It's another way to look at the p-value.
That's a T stall equals X bar minus.
Yeah, well, yeah, if it was T star, So Z star was, this is what we used right there, X bar 1 minus X bar 2 over all together. This business. If it was T-scores I was using, the only real change, which isn't really a change, is these would have been S's.
What did you use to get P?
So the p-value is always the area in the tail that your z-star makes. So our 1.42 made this tail. It's got this much area in it. I looked it up on the z-score chart. Yeah. I like it. I like it. Cool. Some of you guys are living the bad news and you're bored to tears. I'm sorry. Bored is a better place to be than confused. So here, I'm going to have you guys try one. This one is exciting because you get to put this data in your calculator and actually calculate your own X bars. Yeah, Jeff, I can't handle it.
So for these, you just leave it at that. With the right conclusion, you just leave it at
Oh yeah, the right conclusion, sorry. I got so excited.
that.
You guys to do your own puzzle toaster. What would the conclusion be up there? Let's finish that out. What do we say right here? Do we find evidence or not? Do we reject the null or fail? Careful.
We failed.
Failed. We didn't make it far enough away. Fail to reject. The null. Fail to support the high. Which one would I base my conclusion on? What was the claim? Go back to the beginning. What was the claim? It was H1. So we would say we have not found sufficient evidence to support the claim that the new toaster toasts quicker than the old toaster or some such thing, right? Okay. So I'm sorry that I keep being boring. This is just grades again, but oh well, too bad. Try this problem out.